Hi everybody. Today we're going to do some double angle identities. This is the middle section of your formula sheet. They're labeled double angle identities. We're going to start with where they come from. So as you can see the relationship, because they are really all related. So if you think back about the sum and difference identities, that's what we're going to relate some of these to. Also, we're going to use some of the the Pythagorean identities. So if you take a look at number 4, we're on page 309, but where we left off yesterday, where it says to take this sine of 2 theta and show that it equals 2 sine cosine. You can see on your formula sheet that this is actually the formula. So we're going to take the sine of 2 theta and turn it into theta plus theta. And then we're going to use the sum identity that goes sine, cosine, cosine, sine. And we're going to put in first angle, second angle, first angle, second angle, and of course the plus sign in the middle. And you can see we get 2 of these sine theta, cosine thetas. And so it really does come from simplifying the sum identity that we had yesterday. So to show you the cosine of 2 theta one, I'll put it over here. We're going to change this to the cosine of theta plus theta, because that's how we get 2 theta. Then the cosine sum identity goes cosine, cosine, sine, sine. And so kind of you can already see it. We'll put in the thetas, because all the angles are the same. And then there's the opposite sign of the plus, so the minus in the middle. And this, of course, results in cosine squared minus sine squared. Now, we're not going to do C, but continuing along with this cosine of 2 theta, if you look at the formula sheet, there are 3 options for the cosine of 2 theta. And whichever one you select is really your choice. I think it kind of depends on the problem. Sometimes subtracting, if you have fractions, is difficult. So a lot of times I would stay away from subtracting 1 and try to go with the cosine and the sine squared because they have the same denominator. But we'll get to that when I'll show you how to use these. But if we start and take a look at, if we start here, whoa, sorry about that. If we start right here, and then we're going to put it in terms of cosine, which means get rid of the sine. So we're going to have that the fact that this cosine of 2 theta is equal to what we know is true, cosine squared minus sine squared. And then we're going to take this out and put it into cosine only. So leave this cosine squared here. And as you know, sine squared is 1 minus cosine squared. If you distribute the negative sign, you get cosine squared minus 1 plus cosine squared. Well, these are 2 we can add together. So we get 2 cosine squared theta minus 1. And you can see that that is the next choice in the list. Then for number 6, if we again start here where we know that the cosine of 2 theta, is equal to cosine squared theta minus sine squared theta. But now we want to get it in terms of sine. So we're going to get rid of the word cosine by substituting in its equivalent 1 minus sine squared. Then we have that another minus sine squared. Combining like terms, we get 1 minus 2 sine squared theta. So all 3 of these, you can see that the other 2 do come from the first one. And selecting which one to use is sometimes the hardest choice. But like with most choices, it's not permanent and you can change your mind. Now we're not going to do all of these, so we're not going to do B, just so you can figure out what kind of space you have. But we are going to do A. And we're also going to just use the formulas. They want us to find all these things. We're just going to do the double angle. So you can see that when there's a 2 in front of your theta, then you're going to use the double angle formulas. Plus or minus